Hey YouTube, Phil20 here today, and we got an unboxing for you. This unboxing is it's electric meter, and you're going to say, well, you got a bunch of electric meters. Well, I don't have this electric meter, and this is a special type of electric meter. It actually does DC true RMS, and it's a clamp meter, so it's really, really cool to me. There are some different kinds out there, but this one does a lot, and it's true RMS. And I feel like Klein tools is a premium product. I don't think that you can get much better than Klein. I mean, Fluke's really good too as a meter, but Klein tools are really, really good too. So I picked this up. I've been needing to get it from a company called City Electric. They're in Johnson City, Tennessee. There's some probably in your region too. You can go check them out. Just type in City Electric and you'll find them. There you go. So what we got here is basically an AC current clamp meter, DC current clamp meter, and it does up to 600 amps on both AC or DC. The AC voltage is 750 volts, the DC voltage is 1000 volts. The LCD display has goes up to 6000. I guess, I'm not exactly sure why. It comes with a case, test leads, and batteries included. It's got a lot of other stuff, but I really only care about one thing, that's DC current, and that is true RMS. And now let me go ahead and tell you why. If I can get this thing open. The reason why is because I'm having trouble, I think, with my solar array. And I want to fix it. I don't want to have problems continuously. We've got a really nice case right there. We've got our test leads. Instruction manual, by the way, you need to read your instruction manual for your electric meters. And the device itself, obviously they want to keep it dry, so they put these anti-moisture packets in there. And this one's got clamp leads that go to it and regular leads that go to it. Let's take a look at, see, there's our clamp leads. And I take it they just screw on. That's pretty cool. So that's really cool. I mean, you got clamp leads like that, they just can't beat that. Let's see how long the test leads actually are. They're made of silicone, really good silicone. They look nice, they feel nice and strong. They're not too long, not too short. There's a magnet on this. Hey, that's not magnetic. You can't see there's a magnet on it, but you know, it'll stick to just about anything. I didn't know that there was a magnet on it. It's solid too. And there's a piece of felt on the back of the magnet so it don't scratch the equipment. Alright, so one way to destroy a charge controller is to put your test leads on the wrong way and start checking things. Make sure your test leads is on black for the black wire and red for the red wire. Because I've blowed up a charge controller doing that. Pretty funny, ain't it? Let's go ahead and take a look. There's already batteries pre-installed. I think there's supposed to be a light here. There it is, the light turns on. turns off with this side button. There's a hold button right there for high amp rush, and then you got minimum and then maximum. That's pretty cool. And then range, non-contact voltage. If you don't know if there's electricity there, just press this button and bam, you know. Electromagnetic fields, it detects electromagnetic fields. Pretty cool. It's not the reason why I got it. The reason why I got it was for DC current. Let's go over here to amps. And what better thing to test it on than my input on my charge controller, and this should measure exactly the same. So let's get over there and take a look and see if it is. Okay, we're back right here, and I wanted to go ahead and show you what's going on. If you can't see it, then I'll take a snapshot. There we go. We've got accuracy is really close right here. This seems to be a bit delayed versus this one, which is no big deal, not too worried about it. What's important to me is that it measures accuracy. So I want to get on the roof and take a look at some strings of panels, because I'm concerned that I don't have all the strings running. So let's get up on the roof and take a look. Okay, YouTube, I'm measuring the voltage between the negative circuit and the positive circuit. This is the power coming out of the combiner box. Let's go ahead and take a look. We're looking at about 78 volts here. And we got 76.3 volts at the charge controller. So if we just take a snap photograph, we can see what's going on with that. Also, I wanted to do some amp metering. Okay, so we got it on amps. Now we got to set it up from alternating current to direct current. Okay, so now we got it on DC, and it says we got 27.42 amps right here, and we got 20 amps down there. So this is the exiting power, and we've got a loose connection between here and downstairs. So I'm going to go to the disconnect and take a closer look at it downstairs. That's on the outside. It's a wall mounted disconnect. We're going to check that. We're going to check all the places and see where we're losing our amps. Because that's 7 amps at 78 volts. That's like a quarter of the power. We got to figure out why we're not running at maximum power. Alright, so we got 22 amps on this circuit right here. And 19.6 amps on this one here. 22, it's going up and down. We got 19.5. We got resistance between one of these circuits. It could be either one on each side. Let's go get the thermal imager and take a picture of what it looks like. So I'm just going to assume that something's getting hot in here. If not, then we're going to go inside and take a look and see where we might have a loose connection there. But no matter what, we got to stop the amps from dropping. So I've taken a couple pictures. Now I'm going to tighten all the screws that are in here up. Make sure that they're maximum not as tight. Now since I tightened it up, I want to check and see if the amps are any different. So currently we got 16.7, 14.3. So I'm thinking that this disconnect sucks real bad, and I'm gonna have to replace it. I've got another one identical to it. I guess I could take the guts out of this one and put it together. I see where it's at. It's burnt right there. Let's take a closer look. It's burnt right there. burnt good on the negative side right there. That's why I'm getting less amps. Now, I did find some screws in the other panel on top that wasn't nowhere near as tight as they should be. And that's my fault actually, but you know, I wanted to go through all the wiring connections and see why I'm losing amps. And it's obvious right here, it's burnt. It's not that big of a problem. My biggest problem is the size of this conduit that I've got going in here. I intended on having a 12-volt battery system back when I first started doing solar, and I run a big conduit outside so I could run, you know, big wire, because that's what I was going to do, make it the most efficient as possible. And I had a MPPT charge controller that would run up to 60 volts instead of 150 volts, which, you know, came on that Ames inverter that I got, and I was going to use it, and then I just never did. But you can see right there where our problem is. It's right there. What I'm going to do is I'm going to take this connector, I'm going to take it out, and then I'm going to go to, I got another one inside the house. I'm going to go and take the parts off of it and put it back on. I'll be right back. Well, that wraps everything up. I just figured I'd stop and let you guys know what had happened, and I wanted to make it as short as possible, so I took a bunch of stuff out. Right now, I think I've got the problem solved. The biggest problem for me is waiting until tomorrow at Peak Solar, if I've got a good solar day, to find out if that fixed our problem. I really think it made an improvement. Now, I can't promise it fixed the problem until I actually see results, but I seen that the amps was a lot closer than they was before and after, and so I'm appreciating it. I'm really excited to see what happens tomorrow. I checked the amps on the charge controller side and the amps on everything, and it just seemed like it was a really good thing that I done this. You know, I had to personally go out and pick this one up. It wasn't given to me like the other one was, but it was worth it. I mean, I'll tell you what, this solar is quite expensive, and if you think about it, I'm not trying to steer anybody away from it, but you know, you got to get everything exactly right. I might end up changing that panel outside to a midnight solar disconnect with breakers or a fuse, because I just can't have to worry about something that's losing amperage and there's, you know, nothing I can do about it. So this is Philip 20 with solar power, electricity, and electronics, and I'll holler at y'all later.